Okay, so we have this movie file now that we made and we were going to send it to a theater. And since that's not going to work out, we got to figure out how do we get this to a TV. And it turns out that TVs aren't movie theaters. They don't play the same formats. And who knows how to work those remotes. So what we need to do is figure out first just what's a common format that we can play for, let's say this TV here. And they're a little tricky because there's different models and different formats that they support, but let's just go with something that's a little bit standard, I guess, or common for this use case. That's just so how we get media in there. So let's transcode this movie file into something that we expect the TV can play. So we'll use this movie, and we could send this to TVs right through the mail. We could actually just like copy these a bunch and put them in envelopes and send them to people and let them play them. But we don't want to use that. We actually want to stream this online. So the first step we're going to need is some sort of like storage of what movies we have. We need some sort of metadata server, some database somewhere that we can put all of these files in, all these movies, and store this metadata so we can get that later and people can look it up and say, okay, what's your catalog? Where's this information? So let's just have some database and put it in there. And then what we actually want to do with the file itself is change it and chop it up into little bits. This is easier to kind of push over to TVs, sort of like packets on the internet, right? We can store all these little files with some reference data, what movie it's in, which part of the movie it is, and essentially where it's stored. And let's just put all of those in a bucket somewhere, somewhere we can access online. Put all these together into what we call a playlist. And this playlist is, we need to store it in our metadata server as well, but it's going to give us the order for all these files so that when someone requests it, they can get those files directly and we can stream it to them. And there you go. We have a stream on a TV, which is awesome, but not the whole story. If we have a TV way over here on the other side of the country, how are we going to get the files to them? We could stream them and send them all the way across from our centralized buckets, but that's probably not the most efficient way to do it. So what we probably want to do is have a bucket that's close to them as well. And we can say, okay, well, if we put it here and we synchronize this data, we can just put all the files over there, then we can send it and it's a lot closer. And again, this sort of makes sense, but not when we have TVs all over the place. We can't just put buckets everywhere. And so for that, we're going to have to figure out something else. But we can rely on this thing we call the 20/80 rule, where 20% of our content is viewed 80% of the time, which is actually really helpful for us because instead of using these larger buckets with all the information, we only need to actually synchronize 20% out to smaller edge locations. And these edge locations, we can use a CDN and just put them all over the place, which is great. And 20% of our data goes here, and the other 80% can still be fetched from these centralized locations. And as the media gets more popular, we can sync it out somewhere else. But now we can sync some of the larger content between these buckets and then from there synchronize to the smaller CDN cache locations and all the TVs can access it. Now what happens when we look at a global view? That still kind of works. We can still store 80% of the content centrally and 20% all over the place, which is actually really great. So I think that would scale for us over the globe. We have the TV here, and if you have a TV, you probably have a phone too. And there's also a good likelihood that you're going to have a tablet or something. And then maybe even a game console. And so how do we get files for all of these things? We can't just send the same files to all of them. And we can, make multiple copies of them, but your TV's probably going to have something like surround sound. So we need another version for that. Oh, and maybe you have HDR. So we might need another version for that. And what if you have a low internet connection? You can't use the really big files. So we need another version for that. And this just keeps going on and on and on. And it gets really messy, but we have to track all of these files in that metadata service so that when the right client tries to access them, they get the file that they want. Let's simplify it though, just that's too much. So now let's look at what it actually takes to open the app. From a user perspective, what sort of infrastructure do we need? And we're gonna need a few things up front for like a sign up service, as I need to be able to create an account. I need to be able to pay for this account, and I need to probably set up some sort of profile. So we're not going to focus on these, but this has pretty standard, user databases and PCI compliance for payments, and some other metadata for which sort of profiles are part of a larger account. But let's focus in on just, let's pretend someone has an account already and they're just going to open the app and try to play a movie. What does that look like for the infrastructure? So first step, we have the app. Let's go ahead and open it up. And the very first thing, of course, when you start an app is you need to authenticate. So we need an authentication endpoint that we're going to get either a token or a username and password just to prove that you are who you say you are. And this service is going to talk to what we call a session service, which will actually make a temporary session for us to allow us to get access to the other backend pieces that we might need. So it's going to send basically just some sort of hash down to the phone that we'll use later. And the first thing that after we've authenticated is we want to load our home screen or the main page. And so we'll look at a list service is what I'll call it here. And this is just going to provide us all sorts of information that goes directly on the main screen. List is made up of multiple different pieces and combines a lot of this information from that metadata service and other places. One of those things that it's going to create or use is a CDN mapping of which CDNs are we using for which locations, because if we want this to be all over the world, we'll probably need more than one CDN. Multiple different CDNs will use different networks more efficiently based on peering and partnerships. So we want to make sure that we're giving the best CDN for the network and client that someone's using. So the second piece here is the client, and that depends on what type of phone you have, what sort of files format does it support, what DRM does it support. All that kind of stuff comes into this client piece where I can see from a request, okay, you're going to want either FairPlay or some other DRM with this sort of file, with this sort of audio, with HDR or not. And then this list will also look at personalization, things like what's on my playlist, what's on my watch later, which things do I recommend to you? And personalization is such a long word, let's not write it that way. Usually people write it as a number nym, which is P13N, which is 13 letters in between. So that's our personalization piece. And the final one is this license service, which will depend on where you're located. If you have if we have a partnership or media rights to play that in your country, things like different files for different countries also matter. If you didn't know, a lot of animated movies have a different version for the United States versus, say, China or Japan or Canada. And so we can fetch some of this stuff properly depending on where your geolocation is as well. So all of these things will work together. So first, our personalization and license service will give us some content based on where you're located and what we think you'll like. And then that CDN and clients will give us what playlists match those files. And so we can say, okay, I'm just going to send you these files and it's going to have all of the playlist information right embedded into it so that when I go to click to play it, it's already there. And this is going to repeat for all these different files that we want to show on the home screen. We could do that for this, hero bar here, but also for all of the other bars that we might have on the home screen to get you the information you want so you can just start playing it right away. But what happens if you want to search for something? That's a slightly different problem for infrastructure. So let's say we want to just text search for a movie. And the first thing search is going to do is it's obviously going to work with that list service. And the list service also can have collections that are either automatically or curated by a person. And so things that go together, things like Star Wars movies all go together or animated films all go together. This is great because we can return all of those. If I search for one, hey, you probably want to see the other ones as well. So list is great at that. But the full text search is a little bit more tricky because we need to rely on what you're typing to not only get the words that you wanted, but maybe something similar to those words. So if you type in a search, let's look at how that flows in this text situation. We'll use that metadata service that we had before, and we can probably just put Solr or Elasticsearch in front of it for a full text sort of view of that metadata. But and we can dump the information in there based on ingest. So when we pull in a file, we can throw that into Elasticsearch. But a full text search of that is going to be a little cumbersome sometimes. So we might need to change that and use something custom. A GraphQL API probably makes a lot of sense here because we can more fine-tune the query that we want to make. And the big benefit here is that 80/20 rule is we can cache it. So 80% of our searches will probably cached, and we only have to rely on Elasticsearch for the last 20%. So I type something in here into the text field, go to GraphQL. That's going to look up in the cache if it's there. If it's a cache miss, okay, now we need to actually fetch the full text and get the result that you were looking for. So we can combine both of these backend APIs into this main search API. And whenever I search for something, send them the 1 or 2 files that we actually want for our result. So here comes our results. And once we get the movie that we actually wanted to watch, that shows up here. And what does it look like to play a movie? Finally, we're there, right? And again, this has all that information of a playlist for where it's located. I can just go access those files directly, but we're missing a step here. There's DRM on these files. How do we understand and read these encrypted files with the DRM? So again, these files are just stored in this bucket, DRM wrapped depending on the clients. And so we need to talk to some DRM service. And remember our session token, that actually is what we're going to use. So the DRM backend knows that our session is going to be valid based on their own communication, but also which token we get. And it's going to give us a key that will allow us to locally decrypt those files. We don't want to do that prior to this. So once I finally get that key from the DRM service, I can access those files, and there we go. Now we're loading. Now we can press play. Except for a couple small things. While I'm playing this movie, I'm going to have a heartbeat service, something that's actually going to call out to some other backends just to kind of let us know where we're at. And the first heartbeat that we're going to actually want to send is back to that session service. I want to refresh this session service occasionally just to make sure that my session is valid, that I still have access rights to get this content, that I can still do things. But that new session also works with this DRM service to make sure that if the DRM key changes for certain files or certain formats, I'm still able to decrypt those, and all of that works works in concert together to make sure that I'm getting the right information. And so what happens if I go offline, right? Like my heartbeat stops. Now what do we do? This is exactly the same problem as, say, download and watch offline. In this case, I get a slightly different DRM key probably that will give me a longer lease on watching those files. So I can prefetch all of the files from wherever they're located in the best formats, and my DRM key will expire at some point, but it'll be more long-lived than if I'm watching with internet connection. So this is great because once I come back online, I can refresh my session and DRM token, and everything else just works. The final 2 pieces here that we want to actually heartbeat to are what we're just going to call the watch endpoint and the metrics endpoint. So watch is super critical for things like continue watching. As I'm watching this movie, I'm constantly sending back a little bit of information where I'm at in the file, which movie I was watching, which timestamp I'm at. That really matters for when I want to pick it up later, either on another device or just later in the day or tomorrow or something like that. And then this metrics endpoint gives a lot of performance about what it looks like to stream this movie. Is my network still fast enough? Is the format good for this device? Have I had any latency or issues? And being able to get that from the client side and match that up with what the back end is seeing is hugely important to be able to understand the performance of the entire stack. And so I can get metrics from both sides, and then get a better picture of what's happening in the service. And that's just a huge win. So there we go. Now we're watching a movie. All of those pieces come together to put this movie together and stream it to my phone.